Hi everyone, welcome once more to this YouTube channel, our Best Science Brain YouTube channel. Today we are taking another chemistry content, general chemistry for first year students in high institution and also for students in polytechnic, university and colleges of education. So we're taking a topic in chemistry. Today's topic we centered on chemical reactions and chemical equation, which is an aspect of general chemistry, or otherwise known as Chem 101 in the university. And also, this topic is also beneficial to students who are doing their JUPEB program. JUPEB is a program done in the Nigerian universities, such that after the program, they can move on to their second year of higher institution. Also, this particular topic is also of importance to students in their final year in high school, that is SS3, in the Nigerian institution, or in the Western world in 12th grade class, so that they have the ultimate class in secondary school, because we know that chemistry involves equations and reactions. All aspects of chemistry involve reactions and equations. You can't talk about reactions. You can't talk about chemistry without reactions, or talking about reaction without equations. So this is your YouTube moderator, Dr. B. So we are once more here. And then if you're not subscribed to the channel, you can subscribe by, as the video is playing, look at the three dots beneath the video, tap on it once, and then tap on subscription if you're not a member of the channel, and subscribe to get more of these videos in chemistry as well as physics. So today we're going to start off with chemical reactions, an important aspect of chemistry. As I said, you can't talk about chemistry without reaction. Well, chemistry deals with reactions or reactivity. So every day we come across reactions. What do I mean by reactions? Chemical changes taking place. For instance, when I expose a piece of iron to air, a new iron nail, for instance, to air and moisture, after some time, the new shiny iron nail becomes brownish in appearance. What has happened to it? The iron has reacted with oxygen, air, as well as moisture, which means water, to form a brownish substance known as rust. So that's a chemical reaction. Another example is if I set a piece of paper ablaze or a piece of wood ablaze. After some time, the paper or the wood burns, turns to ash, and gives us some gases. That's also a chemical reaction taking place. So that is chemical reactions in chemistry. And then, having done that, we are now going to define chemical reaction. What do you understand by chemical reaction in chemistry? So that chemical reaction is a process by which one or more substances known as reactants are converted into new substances known as products. During a chemical reaction, the bonds in the reactants are broken and new bonds are formed in the product. So let's go through what we have on the board. We said that a chemical reaction is a process by which one or more substances known as reactants are converted into new substances known as products. During a chemical reaction, the bonds in the reactants are broken and new bonds are formed in the product. I repeat, the chemical reaction or chemical reaction is a process by which one or more substances known as reactants are converted into new substances known as products. During a chemical reaction, the chemical bonds or the bonds in the reactants are broken and new bonds are formed in the product or products. So that is how we define a chemical reaction. So a chemical reaction signifies a chemical change. It's a chemical change whereby a substance is changed to another substance. For example, the first example I use in this class, whereby iron, when a piece of iron is exposed to air, after some time the iron turns brownish because the iron has reacted with oxygen as well as water to form rust. Also, when you put some maize inside a container and pour water into it and leave for some days, after some time you observe that the maize has become soured or has turned soured. So fermented, because there's a kind of biochemical reaction taking place in it, changing the fresh maize into a different substance altogether. Just like when you have fresh palm wine contains glucose and yeast. After some time, leave for some time, for some days, the fresh palm wine becomes sour and becomes intoxicating because the glucose in it is being converted to alcohol. That's a chemical reaction taking place. So in this video, we are not interested in going to the types of chemical reaction. That'll be our next topic. Today, our interest is on chemical equations. But we cannot talk about chemical reaction without talking about chemical equations. So how to define chemical reaction before we go to chemical equation. So now we're going to chemical equations. So now we move to chemical equations. So in chemistry, when a reaction takes place, we have to represent the reaction using what's called a chemical equation. For instance, assume that substance A combines with substance B to produce substance C and D. So perhaps carbon could be substance A and B could be another substance like an acid, giving you different products. So this is the chemical equation. When you represent a reaction using chemical symbols and chemical formula, what we obtain is called a chemical equation. We use chemical symbols if the substance is reacting are elements. We use chemical formula if the substance is reacting or produce are molecules or compounds. So a chemical equation is nothing but a symbolic representation. Chemical equation is a symbolic representation of reactants and products involved in a chemical reaction. So chemical equation is a symbolic representation of reactants and products involved in a chemical reaction. So that is what is meant by a chemical equation. For instance, in an illustration above, A plus B giving us C and D. The substance is written on the left-hand side with their formula or their symbols are called reactants. while the ones written on the right hand side are called products. So as I said, a reaction can involve two reactants, two products. You can say involve one reactant. For instance, you can have a reactant like AB splitting into A plus B. So you can say have one reactant and two products, two reactants and two products. You can still have three reactants and three products, and so on. The more important thing is that the substances you write on the left hand side of the equation are reactants, while the ones whose symbols or formula appear on the right hand side are called products. Symbols represent elements. For instance, if A is zinc, the symbol of zinc is Zn. Then if B is chlorine, chlorine is Cl2. It has given us zinc 2 chloride. You see that? So this is a symbol, this is also a symbol, while this is a formula of a compound. So a chemical reaction can involve symbols of elements or formula of compound. Depending on what the reactor, it could be elements reacting with each other to give you a compound. It could be compound. For example, HCl reacting with another compound to also produce compounds. So compounds refers to the representation of symbol refers to the representation of elements, while formula refers to the representation of compounds. So these are formulas that involve two or more elements together. While these are symbol, this is a formula. So having done that, we're now going to look at the key concepts, the concepts of chemical equation. What are the terms we deal with when we discuss chemical equations? So we'll now look at the key concepts of a chemical equation. What term do we use to describe a chemical equation? The first term is called reactants. So reactants refer to the starting substances involved in a chemical reaction. For instance, we have A molecule plus B molecule giving us 2AB. So these substances that combine, the starting substances are called reactants. So A and B are the reactants, or rather A molecule and B molecule are the reactants. Then products. The products are the substances or the substance formed at the end of the reaction. So the product is placed on the right hand side across the arrow. So AB is the product. So in this reaction, two molecules of AB are produced. So AB is the product, while A molecule and B molecule are reactants. 2AB refers to the products. Then energy changes. During a chemical reaction, energy is either absorbed or evolved. So that's what we call enthalpy of reaction. If energy is absorbed, we say that if that reaction absorbs energy from the surrounding, we say that the reaction is endothermic. Endothermic. Or if the reaction gives out heat energy to the surrounding, we now say it is exothermic. So how do we know that a reaction is endothermic or exothermic? Most reactions, you see this symbol, which is called the enthalpy change, the heat change of the reaction. So when the symbol bears a positive value, for instance, plus 100 joules, positive value means endothermic. What it means is that 100 joules of energy was absorbed by the reactants to break the bond and to form the product during the reaction. So positive means endothermic. Then when it is carry negative, it means reaction is exothermic, means that 100 joules of energy was given out during the reaction. So another key concept of chemical reaction is conservation of matter. All balanced chemical equations obey the law of conservation of matter or mass, which states that matter is neither created nor destroyed in the chemical reaction, but can be changed from one form to the other. I repeat, matter is neither created nor destroyed during a chemical reaction, but can be changed from one form to the other. So all balanced equations obey the law of conservation of matter. How do we explain this using this simple equation? Let's go to this equation. If I draw a table, right here, reactants, right here, products. The reactants are A and B. Also, the products, the elements there are A and B. Let's count the atoms. There are 2 atoms of A here. There are 2 atoms of B also there. On the product side, there are 2 atoms of A because the 2 in front, what does it mean? The 2 in front multiply each atom behind it one after the other. So there's 1 atom of A times 2 giving you 2 of A. There's 1 of B times 2 giving us also 2 of B. That means this equation is balanced and obeys the law of conservation of matter, whereby the number of atoms on the left-hand side and the one on the right-hand side are equal. If I calculate the total number of atoms here, 2 plus 2, 4. 2 plus 2 also 4, meaning that the equation is balanced and obeys the law of conservation of matter. Had it been the number of atoms on this side and this side are not equal, that means the equation is not balanced and it does not obey the law of conservation of matter. And that key feature of chemical equation is reaction conditions. In some instances, the reaction conditions will be given to you either above or under the arrow. What are these conditions? Every reaction occurs at a specified temperature, specified pressure, specified concentration, and perhaps specified catalyst. So that's why sometimes you can see something like 100 degrees Celsius, maybe 180, and written above the arrow. What it means that this reaction is occurring at a temperature of 100 degrees Celsius and pressure if they are gases of 1 atmosphere. So these are the reaction conditions, sometimes specified in the chemical equation. So having done that, the next thing we're going to now is the balancing of chemical equations. We're going to learn how to balance what is meant by balanced equation and how to balance chemical equations. So look at the board, balancing of chemical equation. Balancing the chemical equation involves adjusting the coefficients in front of the chemical formulas to ensure that the law of conservation equation. Let's take a real example now. Let's assume that we have HCl plus sodium hydroxide, sodium chloride and water. The question is this equation balanced? How do we check whether it's balanced? all you have to do is to draw a small table. You can write here atoms, right here left hand side or reactants. Is the left hand side or reactants? Right this side, right hand side or products. You see that you notice that the elements on this side also appeared on the other side. Hydrogen is here, you can see it over there. Chlorine is here, you can see it over there. Sodium is on the left hand side, you can see it over there. Oxygen is there, you can see it also over there. The elements appeared on both sides, but the difference is that the compounds are not the same. The elements rearrange. How are they rearranged? You see that sodium, just pick chlorine to give you sodium chloride. While hydrogen, pick OH, give us water. So that's the equation we have here. So now we are here to come to how to write equations. So having done that, we are now going to ask ourselves, how do we now check whether this is balanced? What you have to do is you write out the elements here. Hydrogen, picking the one by one. Chlorine, separate elements. Sodium, then oxygen. There's also hydrogen, but I'm not going to write this hydrogen again because it had been written before. So don't repeat element twice, even though it appeared twice, write it only once, symbol once. So hydrogen again, chlorine, sodium, and then oxygen. The elements that appeared here also appeared on this side. So no need to write them here also, because that shows the law of conservation matter, showing that we do not produce a new element. Had it been that we had maybe calcium bromide plus maybe fluorine, look at this. Is this possible? The answer is no. There's no how to manufacture this from that in chemical reactions, because these elements are entirely different from this. If this were to be possible, we would have said that matter had been destroyed and new ones have been created. So since it's not possible, we still get the same elements on this side, but in a rearranged manner. So we now have the right thing, NaCl and water. So let's check how to balance, whether it's balanced. Let's pick it. We now move to hydrogen, the first element here. There is one atom of hydrogen here, and that atom of hydrogen here. So 1 plus 1 gives us 2. Go to chlorine. Look on the two elements, the two compounds. Chlorine only appeared here. There's no chlorine here, so 1 chlorine here. Go to sodium. There's no sodium here. Sodium appeared only 1. The number of atoms in the frequency, there's 1 sodium. Go to oxygen, it appeared only once, 1 oxygen. So we accounted everything here. So let's go to the product side. Hydrogen first. There's no hydrogen here. There is 2 frequency, number of times 2 of hydrogen there. Then chlorine, there's also only 1 of chlorine. Sodium, there's 1 of sodium. Oxygen, there's 1 of oxygen. You see that if we add the number of the atoms are all equal on both sides. If we add the whole atoms, this is 5. Which side is also 5. That means the law of conservation of mass is obeyed. So this is a balanced equation, the way you are looking at it. So having done that, let us take another example. H2SO4 plus NaOH, giving us Na2SO4 plus H2O. So let us check whether this equation is balanced. And you know, mind you, that in chemistry, if an equation is not balanced, it is meaningless. It makes no sense. So you must make sure that you balance all chemical equations before proceeding to answer some other questions. So let's go on. Atoms, left hand side, right hand side. So the first element here is hydrogen. The right elements one by one. Sulfur, oxygen, sodium. Oxygen has appeared before. Hydrogen has appeared before, so don't repeat them. So we now count. Hydrogen is 2 atoms here. Frequency, there is number of times 2. Only 1 here. So 2 plus 1 on the left hand side gives you 3. Then sulfur is 1 here. You can see that. Then oxygen, we can see oxygen is 4 plus 1, giving us 5. Sodium, giving us, we're taking out sulfur as 1. Oxygen is 4 plus 1, giving us 5. Meaning sodium, which is only 1. Go to the right hand side. Sodium is 2. You can see sodium 2 here. Okay, I will have started from hydrogen. Let's move from the beginning. Hydrogen atom here is 2. You can see 2 there. Then sulfur is only 1. You can see 1 there. Oxygen is 4 plus 1. That gives you 5. Sodium only 2. Frequency 2 here. So you check the equation very well. You see that this equation is not balanced. Look at hydrogen, 3 and 2, they are not equal. Sulfur appears to be balanced. Oxygen is balanced. Sodium not balanced. As long as one or more atoms is unbalanced, the equation is not balanced. Even if all the atoms are balanced except one, it means not balanced. So if you add up, you see 4, 9, 10, the number of atoms. So this side, 3. Let's get it. This 4, 9, 10, 3, 8, 10. Even though it's 10, quite alright, but even though the number of atoms appear to be equal, this could be misleading. You can see 3 plus that's 8 plus 2, 10. 4, 9, 10. Even though you have equal number when you add up, but provided the atoms here are not balanced, not minding that you have equal number when you sum up everything, the equation is not balanced. So let this total number not mislead you. So you have to make sure that if you have 2 here, here is also 2. If you have 3 here, here is also 3 for you to say it's balanced. Now what do? Let's now look at the equation again and make some changes. I'm going to make some changes on it and cross check again. So let's see. Okay, let's check it again. We have put some coefficients here. I put 2 in front here and put 2 in front there. So let's cross check the equation once more. So if we cross check again, let's list the atoms again and then do the check. So hydrogen, sulfur, oxygen, sodium. No need to write O and H again because they are already been written. Hydrogen, now let's count. There are 2 atoms, so the frequency of hydrogen atoms. And for this one, as I told you, the number in front, multiply the elements behind it one after the other. So the hydrogen here is 1, multiplied by these 2 is 2. 2 times 1, 2, plus the 2, the other gives hydrogen 4. Going to sulfur, there's no sulfur here. Look at sulfur here, it's only 1 atom. Oxygen, there is 4 for oxygen here. And there's, okay, here, oxygen here is 2 times 1, 2, plus this 4 here, that gives us 6. Going to sodium. Sodium here is 2 times 1, that gives you 2. Remember that this number, we multiply all the number behind, the element behind one after the other. I repeat myself, hydrogen is 2. 2 times 1 is 2. So 2 plus 2 is 4. Sulfur appeared only here, not in this compound. Sulfur is 1. There's no number close to sulfur. This 4 belongs to oxygen, not to sulfur. Sulfur is 1 atom. Oxygen is 4 here. Then 2 times 1 here is 2. Plus 4, 6. Sodium is 2 times 1, giving you 2. So what it means, there are 2 sodium atoms inside this compound, 2 oxygen atoms, and 2 hydrogen atoms. So let's go to the other side. Hydrogen, there's 2 in front. 2 times this 2 gives you 4. For sulfur, there's only 1 sulfur there. For oxygen, there is 4 of oxygen here. Then 2 times 1, 2. 4. 2 times 1, 2. So 4 plus 2 gives you 6. Then for sodium, there are 2 atoms of sodium here. We have 2 here. So you see that in this case now, the atoms are all equal. 4, 4, 1, 1, 6, 6, 2, 2. So it's a balanced equation. If you add 5, 11, 5 plus 11 plus 2, 13 atoms altogether. 5, 6, 11, 13 all together. So it's a balanced equation. Not only because they have equal number here, you check all the atoms, they are equal on both sides. So having done that, we're now going to learn how to balance chemical equations properly. So we'll now go to steps involved in balancing chemical equation. The first step says, write the unbalanced equation. Start by writing the chemical formulas of the reactants and the products. So for you to balance an equation, you must know the equation you want to balance. You must know the reactants, their formulas. You must also know the products that should be produced, and also is or formula or their formulas if there's more than one product. Then number 2, balance the element one by one. Begin with the elements that appear in the least number of compounds and balance them first. Okay? Number 3, adjust the coefficients, that's the number of moles. Use the smallest whole number, and that whole number is 2. You start by using 2. It's a kind of try and error method. The smallest whole number as coefficient of each substance. Number 4, check the balance. After adjustment, ensure the number of atoms of each element is the same on both sides. I repeat, step 1, write the unbalanced equation. Start by writing the chemical formulas of the reactants and products. What it means is that you should know the reactants and products for that particular reaction. For instance, carbon reacts with oxygen to give you carbon 4 oxide. You should know that the reactants are carbon and oxygen, and then carbon 4 oxide is the product. Then number 2, balance the elements one by one. Begin with the element that appear in the least number of compounds and balance them first. Number 3, adjust the coefficients. Use the smallest whole number as coefficients of each substance. Number 4, check the balance. After adjustment, ensure the number of atoms of each element is the same on both sides. So having done that, so these are the steps we'll try to follow when we want to balance the equation, but it is proper for us to use a real equation and explain this. So we're going to use examples now. Some examples of equations that are not balanced and then balance them, from the simple ones to the harder ones. So let's take an example of an unbalanced equation. One example is this reaction between hydrogen and chlorine to give you hydrogen chloride. So let's see, is this equation balanced? How do we balance it? So all we have to do is we draw a table here, left hand side. Remember that LH means left hand side. This is right hand side. Left hand side indicates the left hand side are the reactants, right hand side the products. Then the atoms. The atoms present hydrogen, only one atom. Don't count the atom number of atoms, the elements, sorry, hydrogen, the symbols, chlorine. So don't take the atom the same time. So the elements here are hydrogen and chlorine. Also on this side, hydrogen and chlorine, as I explained before. Now, hydrogen is 2 atoms here. Chlorine is 2 atoms on the left hand side. Right hand side, hydrogen is only 1 atom. Chlorine is only 1 atom. Then in the equation balance, by inspection, the equation is not balanced at all because you have unequal number for each atom on both sides. What do? You want to balance an equation, what you do is you inspect the table they are written and then look for the element that is not balanced. In this case, both of them are unbalanced, but you have to start with only one of them at a time. You don't have to balance the 2 of them at the same time. So let me take only one of them, hydrogen. So balance hydrogen, I'll ask myself, what number why use? What is this number? Why you to multiply this smaller value 1 to give you the bigger one 2? To multiply and not add. Find out the number counting from 2 upwards, 2, 3, for any integer, positive integer, you're going to multiply the smaller value to give the bigger value. The bigger value here is 2. So the number that can multiply 1 to give us 2 is 2. So multiply this by 2, it gives you 2. So that gives you 2. Now when you have done that, the number that the element that increase its number is hydrogen. Which side? On the right hand side, that's the product side. So these two, you apply the 1, you write it in front of the compound, never inside. It is wrong to write this. No, this is very wrong, because if you do it, you are changing the formula and giving you a wrong, and that'll give a wrong formula. So the number the coefficient you put in, you want to use to multiply, must be placed in front. So that means hydrogen now 2. Before you go ahead to balance chlorine, you don't just rush to chlorine. You have to change this side first, because the 2 you place in front of hydrogen will also affect chlorine. So I have to change this table before I talk about balancing again. So if I look at the equation, you see that here 2 times 1 is 2. That balances 2 times 1 to that balance hydrogen. Then 2 times 1 here, because these 2 will also affect chlorine, will also give you 2. So that means chlorine is also 2. So the 2 has affected hydrogen, also affected chlorine, making chlorine also 2. So that means the equation already balanced 2, 2 here, and also 2 here over there. That made the equation a balanced equation. So having done that, we take another example and show how to balance equation. And the example is the reaction between hydrochloric acid, which is HCl, and sodium triazocarbonate, giving us NaCl, CO2, and then water. So let's see how to balance this equation. For us to know whether it's balanced or not, before we start balancing, we have to list the atoms first. When we list the atoms, we count on the table and see whether it's balanced or not before we start adjusting. So we have a table on our rough atoms, left hand side, right hand side. The atoms are hydrogen, chlorine, sodium, carbon, oxygen. So having done that, we list that the elements, we listed, sorry, not the elements, then we now count the atoms. Hydrogen is 1 atom here, chlorine 1, sodium 2, carbon 1, oxygen 3. Move to the other side. Hydrogen 2 atoms, chlorine 1, another chlorine here, this is chlorine 1, sodium 1, carbon, this is not carbon, this is chlorine, Cl, look at carbon, only 1 atom, then oxygen 2 plus 1, that gives you 3. You check the equation, inspect it, the table, and see whether it is balanced. You see that there's this place, hydrogen is not balanced, 1 and 2, sodium is not balanced. Sodium is 2 and 1, asterisk. Carbon appear balanced, oxygen appear balanced. As long as 2 elements are not balanced here, the whole equation is not balanced. So we have to work on the equation. So we have 2 elements there that are not balanced, hydrogen and sodium. As I said, when you want to balance, start with one of the elements, hydrogen or sodium. Start one of them. To balance this one, what do? You now multiply, check a number that will multiply the smaller value. For hydrogen, the left hand side is smaller. That is 1 out on the right hand side. So find a number that multiply 1 to give you 2, and that number is 2. 2 times 1 gives you 2. And the number, take it and put it in front of where you have Hc, where you have hydrogen, on the left hand side. So having done that, you see that by doing that, chlorine has changed. So before you go on to balance sodium, you have to change this table again. So what it means is that once you put a number here, change the table before you balance the next atom. So having balanced hydrogen, chlorine now turns to 2 times 1, 2. So chlorine becomes 2 also as well. By so doing, chlorine remains on balance. So by placing hydrogen, we are displeased chlorine. So we have 2 atoms now on balance. So this is now removed. We now have chlorine and sodium on balance. So you start with anyone, doesn't matter. You can start with anyone that's covenant. Anyone you can multiply by a whole number to get the bigger number. So for sodium, 2 times 1 is 2, or with chlorine, 2 times 1 will still give you 2. Anyone of your own choice. So let's start with sodium. Multiply by 2 here. That gives 2 for this side. So look at sodium. This is the right hand side. Look at where you have sodium. You put 2 in front. And when you put 2 in front, before you go ahead to balance chlorine, sodium is not alone with its chlorine. So change the chlorine atom on this side. So sodium is 2, chlorine also becomes 2 times 1, 2. So chlorine has become now 2. By placing sodium, we have also placed chlorine. So you can see 2, 2, 2, 2, 2, 2, 1, 1, 3, 3. The equation is now balanced. So you can see that a very simple illustration of how to balance equation. So we'll look at another example on the whiteboard. The situation of equation balancing. This equation is not balanced. Let's check very well. These are the elements and then check the atoms. Left hand side, right hand side. Elements on sodium. Inside water you have hydrogen and then oxygen. Listen it. Sodium is 1, hydrogen is 2, oxygen is 1. Sodium 1, hydrogen 1 plus 2 is 3, oxygen 1. So take a few seconds to look at the board. When you look at the board, you see that there are 3 elements listed: sodium, hydrogen, and oxygen. And all the elements are balanced except one. Sodium is 1, 1, balanced on both sides. Oxygen 1, 1, balanced on both sides. Only hydrogen is unbalanced. So what do? We ask ourselves, which side of hydrogen has a smaller number? It is the left hand side. You ask yourself, which number, whole number, will multiply 2 to give us 3? There is no whole number that can multiply to give us 3. It's impossible. So you start wondering, what do? Does it mean that the equation cannot be balanced? Or does it mean that the equation is not correct? No. You can balance it, the equation is correct. So since you cannot balance this, had it been that I had 2 and 1 here, what I've done is this. If this one cannot be balanced, I'll go to this one that can be balanced easily and balance this one first before I start considering this. So, but in this situation now, these two are balanced, except only one. I cannot balance this one with a whole number. What do? You now unbalance any of the balanced elements. You unbalance either sodium or oxygen using the least number. The least possible number to balance is 2. So you unbalance any of these that's unbalanced. So let me start with sodium. I'll multiply sodium by 2, left hand side. So I'll now put 2 here. Then to balance it on the other side, I multiply it by 2 on the right hand side, and now put 2 in front here. So sodium becomes 2. Oxygen becomes also 2 on this side. You can see what is happening. Oxygen is 2. 2 times 1, 2. Then hydrogen is 2 times 1, 2, plus 2, 4. Hydrogen becomes 4. 2 times 1, 2. Because this number you put in front, remember, you're going to affect sodium, oxygen, and hydrogen. So hydrogen becomes, sodium again is 2. Oxygen 2 times 1, oxygen becomes, okay, hydrogen is, let's come again. Oxygen becomes, well, balanced oxygen 2 times 1, 2 for sodium. That's balanced. Oxygen 2 times 1, 2. Hydrogen becomes 2 times 1, 2 plus 2, 4. Hydrogen becomes 4. So you see that by unbalancing sodium, we are created a kind of a rearrangement of the atoms, a different scenario now. So having done that, you go to the board again. Now it becomes somehow easier to balance, because you see that 2 is the multiple of 4 is the multiple of 2, and 2 is the multiple of 1. So it becomes easier for you to balance now. Now you can start with hydrogen now, or you can start with oxygen. So then we start with hydrogen. Find a number that multiplies these 2 to give you 4. And that number, of course, is 2. You increase hydrogen on the left hand side, which is here. Water, where you have hydrogen, you put 2 in front. That makes hydrogen 4. As you can see that. Then oxygen, because this number will still affect oxygen. So oxygen becomes 2 times 1, also giving us 2. So by so doing, you have 2, 2, 4, 4, 2, 2. The equation becomes balanced, which previously looked as if it's impossible to balance it. So you can see that. So we'll take another example of equation and see how we can balance the equation. So let's look at the problem on the board. Aluminium and oxygen giving us aluminium oxide. So to balance this equation, we have our atoms, then left-hand side, right-hand side. Pick the atoms, the elements, the symbols, A, L, and O, oxygen. Count the atoms. Amino is 1, oxygen 2, amino on the other side 2, oxygen 3. So we want to balance this equation. What do? We see that the two elements are unbalanced. So we have to start one of them, the easier one to balance. So you look at oxygen, no number multiplies to give you 3. It's impossible. If I look at aluminium, if I multiply this by 2, I will get 2 that side. So let me put 2 here. We are still trying it. So this is a matter of try and error. So we are balanced aluminium. And then 2, remaining oxygen, the situation of all the 2 elements in the compound. So what do we do to oxygen? Becomes somehow difficult or pretty difficult to balance. What do we do? So have 2 and 3. So if there were a third element there that is also balanced, we would have started thinking of how to unbalance one of them, and as we did in the previous case. But in this situation, we only have 2 elements. So what do we do to oxygen? Do we leave it at that? There are no number that can apply to give you 3. So there's oxygen here, oxygen there. We now ask ourselves, we can apply fraction. Is there a number that can apply, any fraction can apply 2 to give us 3? Remember that 2 is not a multiple of 3. But if I divide this 3 by this 2, I'll have 3 over 2. If I multiply 3 over 2 by 2, I'll get 3. Repeat myself. So if this cannot divide this is a factor of this. If I divide 3 by 2, the bigger number by the small number, I have 3 over 2. 3 over 2 multiplied by 2 give us 3. So, and if I put the 3 over 2 on this side, it only affects oxygen, which we want to balance. So 3 over 2 times 2 give you that 3. You see, it's as simple as that. But since we don't normally balance equations using fractions, we balance number with whole number according to Dalton's theory. So what do? We have to change this fraction to whole number. How do we do that? Multiply everything by this denominator, by these 2. So multiply the coefficients by the denominator. So 2 times 2 here gives you 4al plus 3 over 2 times 2 gives you 2 cancels 2, giving us 302. Then 2 times 1 in front gives you 2al2o3. If you check, you have a balanced equation. We have 4 atoms of aluminium, 2 times 2, 4. 6 atoms of oxygen, 3 times 2 is 6, 2 times 3 also 6. We now have a balanced equation. So, having done that, let us continue. We now look at miscellaneous problems. We have one on the board. Equation that says balance the equation given below. So before we go on, we'll still have to do it as we did the previous ones by drawing a sample table, listing the elements. Then, okay, elements or atoms, doesn't matter. Then left-hand side, number of atoms, right-hand side. Elements or the symbols here, list them: carbon, oxygen, Fe means ion. Oxygen have written before, so no need to write oxygen again. Don't write element twice. Then count the atoms. Carbon didn't appear here, it's only 1 atom. Oxygen 1 plus 3 gives you 4. Ion 2. You go to the other side, carbon is 1. Oxygen 1 plus 2 gives you 3. Ion gives us 1 here. So having done that, we look at the equation. We see that carbon is the only atom that appear to be balanced. Oxygen and ion are not balanced. Which one will be easier for us to balance? If we look at them very well, we can't balance oxygen easily because 4 is not a multiple of 3, meaning that no number multiply 3 to give us 4. So run away from oxygen and go to ion. 2 and 1. Look for a number that multiply the smaller number to give you this. Is there a number like that? Yes. 2 multiply 1 give you 2. So multiply this side by 2, which is the product side for iron. Go to the product side, you see iron, you put 2 in front. Before you go ahead, you have to change the table. What are you going to change? The oxygen. So oxygen here becomes 2 times 1, 2, plus this 2, that is 4. Oxygen turns to 4. You see, by balancing iron, you also already balance, you also balance what? Oxygen. So that is the balance equation. So we take another example. So look at this problem on the board. Balance the equation given below. So have the atoms listed, the left hand side, the right hand side of the equation. The elements one by one: potassium, nitrogen, oxygen, carbon. Oxygen have written before, so don't write any element twice. So they can the atoms. Potassium is 1 atom here, nitrogen 1 atom, oxygen 3 plus 1, 4, carbon 1. On the other side, potassium is 2, nitrogen is 1, oxygen 2 plus 2, 4 plus 1, 5, and then carbon is only 1. So, having done that, we inspect the table and look for the one that will be easier for us to balance. You see that potassium is unbalanced, oxygen is unbalanced, these 2 elements. So which one will I start with? So we're going to start easily with potassium because 1 is a multiple of 2. That is 1 by 2 having a remainder. We'll have no remainder. But 5 is not multiple of 4. So this will not be easy. So multiply this side by 2, left hand side. Look at potassium, you put 2 there. So you don't go and balance oxygen. You have to change the table. What I mean by change, you're going to change these elements under behind it before you balance again. So once you place a number in front of the substance, make sure that side is changed before you start balancing again. That's the way it goes. You don't balance this one and then go to this one to balance it. No. Because this number will affect every other element behind it. So nitrogen now becomes 2 times 1, 2. No longer 1. Or becomes 2 times 3, 6. Plus this one here, which is a 7. You can see that. So having done that, we have now 2 elements standing, nitrogen and oxygen. To balance nitrogen or oxygen, which one is better? We're going to balance this one first because 1 divided 2 is 2. 2 is a multiple of 1. So, but 7 is not a multiple of 5. Number multiply 5 gives you 7. That's what I mean. So this one now, 2 multiply 1 gives us 2 for nitrogen. So looking at this, the right hand side, look at nitrogen, you put 2 in front of it. Before you go on with oxygen, you're going to change because this 2 also covers oxygen. 2 times 2 is 4 for oxygen, plus this 2, 6, plus this one, 7. So by pleasing nitrogen, we have also pleased oxygen. So we'll have a balanced equation. We also have another exercise on the board. So this exercise, we have to balance this equation. So we'll still draw our table and lead the elements one by one. Sodium, 1. Okay, sodium symbols first. Carbon, oxygen, O. Carbon written before. Nitrogen, N. We then count the atoms on the right hand side, left hand side. Count the ones on the right hand side. So sodium is 2 atoms. Carbon is 1 plus 1, 2. Oxygen is 3. And then nitrogen is 2. Go to the product side. Sodium is 1. Carbon, 1 plus 1. Carbon here, that is 2. Nitrogen, only 1. Oxygen also 1. So we'll now start we went back on the journey of balancing the equation. They identified unbalanced atoms, sodium, oxygen, nitrogen. So each of them is easier to balance because 1 times 2 will give you 2, 3 times 1 gives us 3, 1 times 2 gives us 2. So you can start with any one you want. So let's start with the first one in that order. So to move this to 2, how to multiply the 1 by 2. Go to the right hand side and put 2 in front of sodium. Look at sodium, we'll put 2 in front. Before we carry on with these ones, this other unbalanced atom, how to change the table. Because these 2 covers carbon and also nitrogen. So carbon now becomes 2 times 1, 2, plus 1, 3. I repeat, 2 times 1, 2, plus 1, 3. So carbon turns to 3. By placing sodium, I have displaced carbon. Also nitrogen, 2 times 1 is 2. That becomes 2. So you can see that. By balancing sodium, I have balanced nitrogen and I have unbalanced carbon. So we'll now move ahead and inspect the equation thoroughly and know what to do. So the equation thoroughly, you see that it's not easy to balance carbon because 2 is not a multiple of 3 or 3 is not divisible by 2. So no number can multiply to give us 3. You look at oxygen, a number can multiply 1 give you 3 and that number is 3. So start with this one that is possible. So multiply this by 3. Good. And locate oxygen on the right hand side. Look at it here and put 3. Before you continue, you have to change the table again because this 3 will affect not only oxygen but also affect carbon. So 3 times 1, 3. 2 times 1 carbon here is 2. So this is 3 here and to giving us total number of 5 carbon atoms. So this carbon changes to 5 atoms here. So it now becomes somehow difficult. You see that you have balanced all the atoms except carbon. And if you go to this side, you have carbon here. This is the side that is smaller, the left hand side reactant 2. Carbon is 1 here, carbon is 1 there. So you have to use the initiative. You see that any number I put here will only affect carbon. Remember that you have balanced sodium. Carbon not alone here. So any number you put here will unbalance or offset sodium and also offset oxygen. So since sodium and oxygen is already balanced, I don't want to unbalance them. Since our pro is only on carbon, that means and carbon stands alone. That means how to find a number that will put here that will only balance carbon. So I want to put it here, it will only affect carbon. You look, here is 5, here is 2, here is 1, 2. If I put 4 here, that becomes 4 carbon atoms, and then 4 will only affect carbon. Then plus this 1 will make it 5. So the right number to put here is now 4. So 4 times 1 is 4, plus this one giving us 5 carbon atoms. By so doing, you are balanced the equation. So in this session, we're looking at balancing of combustion equations. Combustion equations or combustion reactions are reactions in which substances are bound in oxygen. So when a substance bonds in oxygen, be it an element, be it a molecule or a compound reacts with oxygen, we say that the compound has the substance has undergone combustion reaction. Among the combustion reactions we have in chemistry is combustion of hydrocarbons, that is, compounds containing carbon and hydrogen only. So when hydrocarbons is burned in oxygen, what we expect to get is carbon dioxide and steam, or I can call it water. Carbon dioxide and steam is produced when you burn hydrocarbons in oxygen. So having done that, so this is a hydrocarbon called methane. Methane and oxygen giving you CO2 and steam. That's the product of them. Whenever any hydrocarbon or any compound containing carbon hydrogen bonds in oxygen, these products must be the products. Now, having done that, let's balance this equation and see how it goes. To balance it, I'll still follow the normal process I've been using the other ones. The elements or atoms, the left hand side, right hand side. The elements here carbon, hydrogen, also you write the symbols only, and oxygen. So having done that, you list the number of atoms of each element. Carbon is 1 atom here, hydrogen 4 atoms, oxygen 2 atoms. Go to the right hand side, carbon 1 atom, hydrogen 2 atoms, oxygen 2 plus 1 gives you 3 atoms. So having done that, you inspect the table, you see that hydrogen and oxygen are not balanced. So you start balancing with the one that's easier, which is hydrogen, because 4 is the multiple of 2, or 2 can divide 4 with a remainder, but 3 is not a multiple of 2. So the number that can apply to give us the bigger number is 2. 2 times 2 gives you 4. So locate hydrogen on the right hand side. You see it here, you put 2 in front. Before you go to oxygen, you have to change the table, because these 2 will also affect oxygen. 2 times 1, 2, plus these 2, 4. Oxygen becomes 4 here now. So by balancing hydrogen, you have increased oxygen as well. Then for you to continue to balance, you're not balanced. Oxygen is now deficient on the left hand side. So by increasing the oxygen to 4, makes it easier to balance oxygen now, because 4 is the multiple of 2. So find the number and multiply it to give you 4. And that number, of course, is, 2. So 2 times 2 give you 4. So you put 2 now on the left hand side. That becomes 2. So by putting 2 in front of oxygen, that makes it 2 times 2, 4. As you can see here. So you see 4 here and 4 there for oxygen, 4 there and 4 there for hydrogen, 1 there and 1 there for carbon. So we have a balanced equation. And that instance is to use another hydrocarbon called ethane, whose formula is C2H6 plus oxygen giving us CO2 and water. So is that the equation you have? So you have to balance the equation. We follow the same process. This is hydrocarbon. Carbon and hydrogen only in the compound is the hydrocarbon, plus oxygen gives you carbon 4 other than steam or water vapor. So how do you balance the equation? You see, follow the same table, elements or atoms, left hand side or right hand side or product side. So have carbon, have hydrogen, have oxygen. If you count, carbon is 2 atoms, hydrogen 6 atoms, oxygen 2 atoms, carbon 1 atom, hydrogen 2 atom, oxygen 2 plus 1, 3 atoms. So let's balance the equation. Let's start. We look at all the atoms are unbalanced. 2, 1, 6, 2, 2, 3. But which of them will be easier for us to balance? So we see that 2 is the multiple of 1, 6 is the multiple of 2, but 3 is not a multiple of 2. That means no number multiplied to give us 3 unless we apply fractions. So let's start with carbon and hydrogen. So to balance carbon, multiply this by 2 to make it equal to 2. So 2 times 1 is 2. Look for carbon, put carbon here, 2 there. And when you put 2 there, the 2 will affect also oxygen. Change the table. 2 times 2 is 4 for oxygen, plus 1, 5. So oxygen turns to 5, this side. Then you see, go back to the table. Hydrogen and oxygen. Oxygen is still impossible to balance with whole number because 2 cannot divide 5 with a remainder. So we still go to hydrogen, 6 and 2. Look for a number that multiplies 6 to give you 2 to give you 6. And that number, of course, is definitely 3. So multiply by 3. That is on the right hand side. Look for hydrogen. You put 3 here. 3 times 2 gives you 6. And that will, of course, also change oxygen because oxygen is in water. 3 times 1, 3. 2 times 2, 4. 4 plus 3 is 7. Changing oxygen to 7. So having done that, we are left with only oxygen to balance. We are balanced carbon, we are balanced oxygen. We are balanced hydrogen, meaning oxygen. So what do? We ask ourselves, is there a number that can multiply this to give us 7? No. There's no whole number like that. Then this oxygen on the left hand side, we check it on the equation. Is it on its own? Yes. It's on its own. It's not with another substance. That means any number I'll put here will only affect oxygen. Other atoms are balanced. If I put 7 here, 7 cannot balance, because 7 times will give you 14. So since 2 and 7 are not divisible, 2 cannot divide 7 or remainder, or 7 is not a multiple of 2, what will I do? I try to apply fraction, because only one element remaining to be balanced, and that element is on its own. So that way you apply fraction to help yourself. So now 2 and 7. What do? You divide the bigger number 7 by 2. 7 over 2. I applied this method before. Then put the 7 over 2 in front of this. That's the left hand side. 7 over 2 times 2 give you 7. So you see, other ones are balanced. Carbon is 2 on both sides. Hydrogen is 6 on both sides. Oxygen, 7. When you count everything here, 3 times 1, 2 times 2, 4. Plus 3, 7, and then 7 over 2, we divide the big number by the small, get the fraction, multiply by 2 gives you 7. But since we want to balance with whole numbers, since that told us that atoms combine in simple whole number ratios, not in fractions, we convert that fraction to whole number. How do we convert to whole number? Multiply all the coefficients by the denominator, the 2 there, multiply it. So with the coefficient by the denominator you have here. So the numbers in front of each substance multiply by 2. So there's one more in front. Now I have 2C2H6. 7 over 2 times 2 gives you 7. 7O2. 2 times 2 gives you 4. 4CO2. 2 times 3 gives you 6. 6H2O. If you check it, you have a balanced equation. You can help me check. 2 times 2 is 4. 4 times 1, 4. Carbon is 4 on both sides. Hydrogen 2 times 6 is 12. 6 times 2 is 12. Hydrogen is 12 on both sides. Oxygen, 7 times 2 is 14 on this side. 4 times 2, 8. 6 times 1, 6. 8 plus 6, 14. That's the balanced equation. So, we're now going to look at an equation or reactions that are somehow difficult to balance. Normally, the complex redox reactions normally gives us headache to balance them. For example, if I have KMNO4 plus HCl, you know, KCl will have multiple products plus Cl2 plus water. So let's say we have this kind of equation. You are asked to balance this redox equation, a complex redox equation. So what do we do about this reaction? How do we go about it? We're given this. So you see that equation balancing is a matter of trial and error. So when you have an equation and you have to balance it, all you have to do is to draw a table. These the symbols of the elements on the left-hand side. The same symbols will be on the right-hand side. Then count the number of atoms on the left-hand side, count the ones on the right-hand side, and then inspect your table and look for the element, the side that has a smaller number of elements, and mark them as asterisk. Then when you identify the element that are not balanced, then look for the one that will be easier for you to balance using whole number. Don't go to the one that is hard for you to balance. For instance, when you have 3 and 6, it becomes easier because 2 times 3 will give you 6. Than when you have 7 and 2, because no number multiply to give you 7. So you start with 3 and 6 than going to 7 and 2. And once you balance by multiplying a number, then that number, move it and put it in front as a coefficient in front of the substance that is, or the element that is balanced. And then change the table, because that number may be in front of a compound. It is going to affect the elements in the compound. Change all the elements in the table and then start again to balance, and so on. So having done that, let's go to this example. I have atoms or elements, left hand side, right hand side. I know that this one is going to be difficult. Potassium, manganese, oxygen, hydrogen, chlorine. The elements potassium, manganese, oxygen, hydrogen, chlorine. We list the number of atoms. Potassium here is 1, manganese 1, oxygen is 4, Hydrogen is 1, chlorine 1. So you can see that. I'll go the right hand side. Potassium 1, manganese 1, oxygen only 1 on that side, hydrogen, you can see it there, 2, and then chlorine 2 plus 2, 4 plus 1, 5. So having done that, we'll now start balancing the equation. So if you look at the equation, you see that potassium appears balanced, manganese balanced, oxygen unbalanced, hydrogen unbalanced, chlorine unbalanced. So the last 3 elements are not balanced. So I can start with oxygen, I can start with hydrogen, I can start with chlorine. Okay, let's start with oxygen. We multiply this side by 4. That's the right hand side. We locate oxygen. Oxygen is found in water. We put 4 in front of water. And that will make hydrogen to become 8 as well. So hydrogen now is changed from 2 to 8 on this side. So having done that, I still go to the table again and then look at hydrogen and the chlorine. Start with any of them. Then let's start with hydrogen. To start with hydrogen, I need to multiply this side by 8. Multiply this by 8. You can see that. The left hand side, locate hydrogen, you put 8 here. That makes chlorine also 8, changing it to 8. So you can see that. So we are balanced potassium, manganese, oxygen, hydrogen, but we have issue with chlorine. We look at chlorine very well. You ask yourself, is there any number that multiply 5 to give you 8? Is there any number that multiply 5 to give you 8? Becomes somehow difficult. And no, there are no number like that. You say access, the chlorine you want to balance. Does it appear on its own on the other side? Let's check whether it's on this on the other side. Yes. Chlorine is here, here, and there. So if you count, it's 5. So what then do we do to make it to be equal to 8? So let's check very well. Now remember that all the elements are balanced except only chlorine. And the number I'm going to put to balance chlorine must only come to chlorine, because if I put it here, where you have chlorine, or here, it will affect manganese and potassium that are already balanced. So my focus is on this chlorine, because whatever I put here will balance everything, because if I put a number here or there, I will not change the whole table. Since I know that all elements are balanced except chlorine, so I tackle this chlorine. So it is then that I can think of using fraction, because it's only one element standing, and that element is on its own. So what would I do? Let's count. 1 plus 2, that is 3. 3 minus 2, that is 8. That is 1 plus 2, that is 3. 8 minus 3, that is 5. I need extra 5 to make this 3 to be equal to 8. So if I put that 5 here, 5 times 2 is 10. Adding to 3 gives you 13, which is higher. The fraction is required. 5 over 2. 5 over 2 times 2 gives us 5. Then plus this 7 plus 1, 8. So it now becomes an easy work to do. So when we have done that, the thing now is to convert everything to whole number. I repeat this process again. When you come across an equation whereby you have balanced all elements, remaining only one element, and that element you are looking for, you look at the equation very well and find out that there's a place where it is on its own, either on the right hand side or on the product side. And it's not easy to balance it, because the number you have here, 8 and 5, 8 are not divisible. You are going to apply fraction. Then go to that place where it is on its own and apply a fraction that will now make everything equal. Like 5 over 2 times this is 5 plus 2, 7 plus this one, 8, that will give you the 8 that you have there. Then you're now going to remove the fraction by multiplying everything by the denominator of that fraction, which is 2. So when you use 2 here, now I have 2KMNO4. That is 2 times 1. 2 times 8, 16 HCl, giving us 1 here, 2KCl plus 2MnCl2 plus 5 Cl2, because 5 over 2 times 2 is 5. Then plus 2 times 8, 8H2O. So you see a very complex or high coefficients. So let's check. Potassium is 2 atoms here. Here is 2. Manganese is 2 atoms, 2 times 1, 2. Here 2 times 1 is 2. Oxygen is 2 times 4, 8. 8 times 1, 8. Hydrogen is 16 times 1, 16. 8 times 2, 16. Chlorine is 16 times 1, 16. 2 times 1, 2. 2 times 2, 4. 4 plus 2 is 6. 5 times 2, 10. Plus 10, 16. So you have a balanced equation. Next, we're going to how to write equation and balance it. Not balancing already written equation, but how to write and balance some equations. So we're looking at how to write a chemical equation, the little steps involved in writing chemical equations that involve mainly two reactants, that's simple equations. So the first step is identify the reactants and products. So for you to write an equation, you must know their reactants. I must be able to predict your likely products. Number 2, write the correct chemical formulas. That is the correct chemical formula of the reactants. And 3, if the reactants are ionic substances. Ionic substances include examples: metals, acids, because acids can organize in water, salts, bases or alkalis. So if the substances, the compounds or the substances that are of this nature, we take them as being ionic substances. Split them into their ions. But if they are covalent substances, do not split them, because covalent substances cannot ionize. So covalent substances are substances that contain two non-metals or gases. We say they're covalent. Then IV, combine the unlike charges to obtain the products. That is, when you ionize ionic compounds, you combine them to obtain the products and then balance the equation. We'll take it once more. Identify the reactants and products. 2, write their correct chemical formulas. 3, the reactants are ionic substances, e.g. metals, acids, salt, bases. Split them into their ions. But if they are covalent substances, do not split. IV, combine unlike charges to obtain the products. V, balance the equation. So let's take some few examples here. So I have an example, reaction involving ionic substances. An example there is write a balanced equation between zinc and hydrochloric acid. The substance is mentioned for you, zinc, and these are the reactants. You find the product yourself. Zinc is an element. So you write zinc, the reactant, the element symbol is Zn. The other reactant is called hydrochloric acid. An acid is a compound. So you try to get the formula correctly. Hydrochloric acid is written as, the elements in it are hydrogen and of course chlorine. So if you don't know your formula, you can go back to your basic chemistry and read how to get formula of compound. But I can still guide you to find a compound, the formula of any compound. Use valency. The valency of hydrogen is 1, or you can say the charge is +1. The valency of chlorine, atomic number of chlorine, remember, is 17. You write the electronic configuration going to be 287. So 7, any element that has more than 3 electrons in its atomos shell is a non-metal. While any element that has less than 3, not more than 3 in the large shell is a metal. So chlorine having more than 7 makes it a non-metal, and non-metals are electron acceptors. So this element will accept 1 electron to make it up to 8 complete atomos shell, and that's the valency 1, or you can say -1 being a non-metal. The valency of non-metal is what's going to accept to make it complete. So this is 7, is a non-metal, it needs 1. If it's 6, it needs 2. If it's 5, it needs 3. Now, having done that, to get the right formula, the elements will change their valency. The number 1 here goes to hydrogen, there's 1 here goes to chlorine. Equal valency cancel out. So this is the right formula. This should be done on your rough. So when you have obtained the right formula, what then do? You want to write the equation. Write the reactant zinc and HCl on a straight line and put a plus sign between them. They are reacting. Does not matter whether you write zinc first or whether you write HCl first. Whether you're saying A plus B or B plus A, they're the same thing. They draw an arrow to show the direction of the reaction. When you have drawn an arrow, since you are dealing with ionic substances, the next thing I said when I did the step is to split them into ions. To split them into ions means you bring down zinc, separate these two elements the way they were before you combine hydrogen and chlorine. Return the valency of each of them. This takes back the valency of 1 or charge of +1, valency of 1 or charge of -1. Good. Valency of zinc is an element. You can't separate zinc into Z and N because it's a single element. So the letters are together. The valency of zinc is 2, or the charge is +2, being a metal. When you are separated, so you see that zinc has no partner under it. But these are two components. What do? You combine unlike charges. When you combine this and that, when you combine, remember that when you combine to form a compound, valency should be a change as well. So 1 from chlorine goes to zinc. 2 from zinc goes to chlorine. Formula of the compound form is ZnCl. To be mindful of the valency change, you can't write the formula by joining elements like that without changing their valency to get the formula of the compound formed. So you have this combined to give you that. While this one combines with nothing because there's no partner combined with. So whenever hydrogen is free to leave, write hydrogen as just H2 because it means it's a gas, it's living on its own. Hydrogen gas is escaping. And as a gas, it exists as not an atom, but as a molecule. Put 2 on it. So when you have done that, the next thing you have to do is to balance the equation. To balance the equation, you check the atoms. Have our left-hand side, our right-hand side. Our zinc, element here, hydrogen, chlorine. Zinc is 1, hydrogen 1, chlorine 1. Zinc is also 1, hydrogen 2, chlorine 2. Having done that, what do? We now balance the equation. To balance, you see that hydrogen is not balanced. 1 and 2, chlorine is not balanced. So you can start with any of them. Multiply this side by 2. You have been taught that. Multiply by 2. Go to the left-hand side and put 2 here. That will also affect chlorine, making it 2 times 2. So by so doing, you have balanced the equation between these two substances. So we'll take another reaction that involves 2 ionic substances. So we have another equation involving 2 salts, that are ionic substances. To write an equation between them, the first thing you have to do is, first of all, these are the reactants, the things we're using to write the equation. Reactants is to get their formula. Sodium is Na. Chloride indicates chlorine. So this compound contains sodium and chlorine, sodium chloride. Then the atomic number of sodium is 11. You should know your first 20 elements. 2, 8, 1. 11. You write the electronic configuration. Sodium, by virtue of not having more than 3 in the atomos shell, the M shell, the atomos shell is a metal, as I said before. Any element whose atomos shell is not more than 3 electrons is likely a metal, although there are few exemptions. So sodium has a metal. The valency is what you're seeing in the atomos shell. The valency of sodium is 1. So I can put 1 here or indicate the charge +1. Then for chlorine, 17, 2, 8, 7. KLM. Having more than 3 is a non-metal. For a non-metal, the valency is how many electrons you're going to accept to make the atom shell up to 8. Subtract this number from 8, it needs extra 1. The valency is also 1, or it's a negative because it's a non-metal. So when you change valency, have 1, 1, equal valency cancel out. The formula is NaCl. If the valencies are unequal, you leave it. Then you go to this one, lead. The symbol of lead is Pb, but they say lead 2. What I mean, the valency of lead here is 2. So now put 2. It's very easy to get this one. But this one, the valence of oxygen is not given to you. Get it from the atomic number. But this one is given to you direct. Lead 2. So being a metal, I can just write 2 or say positive. Triazonitrate. Tri means O3. Nitrate means N. So this group of atoms, when you have this kind of word, triazo, diazo, tetraozo, we call them radicals. This radical, the Roman number 5, V, doesn't appear in the formula. Maybe subsequent video, I'll tell you the essence of this 5. That 5 represents what's called the oxidation state of nitrogen. So all radicals have their valencies that can be calculated, but for time frame, we may not go into the calculation now. But if you want to calculate it, you can call here S, that's the valence of the whole radical. How do you get this S? You add the oxidation state of nitrogen plus the oxidation state of oxygen multiplied by 3, because there are 3 atoms. So nitrogen is this 5 here, see nitrate 5. While oxygen is minus 2, so is minus 2 times 3. That becomes 5 minus 6 minus 1. But don't worry about this. Just know that the valency of this radical is 1 or minus 1. But after the class, I'm going to list the common radicals and the oxidation state so you can get used to it without going through the calculation process. So that nitrate has state of minus 1. So when you now exchange, you have PbNO3. This one goes to lead. No matter what I'm taking the number, I'm not taking the charge. This 2 here goes to NO3 because this is a group. You don't go and put 32 here. They are together, NO3. So the 2 will now be belonging, you have a bracket to show that the 2 belongs to both nitrogen and the oxygen. So when you want to donate a number to a radical, you have to put a bracket before the number comes in. So that's the formula. So to write the equation now, what then do we do? To write the equation, I'll write the formula of the substances NaCl plus PbNO3 bracket 2. So having done that, what then do we do? We now split them into their ion the way they were before we combine. Separate them. Sodium separate from chlorine. Lead separated from NO3. The components separated again as they were before you combine. Return their valencies, so this is plus 1 or 1. 1, chlorine minus negative charge. Lead is 2, and put plus, so that is nitrate is minus. But at these 2, I did not put the 2 here. No, because these 2 refer to the valency of lead. So when they separate, their valence, they take back their valence. So lead takes back the 2. So when you have done that, you marry unlike charges. So this one moves to this. This one moves to that. So when you combine this, lead 2 and chlorine. When you combine, valence is exchange again. 2 goes to chlorine, 1 goes to lead. Formula, you have PbCl2 produce. Then when we combine this to Na plus NO3 minus. Valence is what? 1. Here is also what? 1. Equivalence do what? Cancel out. When they're equal, you can cancel them and join. You don't need to exchange again. So that'll be a waste of time. 1, 1, cancel. You join them, have NaNO3. Having gotten that, what then do we do? We have gotten the product formula and the reactant correct formula. What then do we do? What we now do is we check the balancing. So draw your table, atoms, left hand side, reactant, right hand side. The elements: sodium, chlorine, lead, nitrogen, oxygen. Sodium is 1 atom here, chlorine 1 atom, lead 1 atom, nitrogen. Lead is 1 atom. Nitrogen is 2 because there's 2 after the bracket. 2 times 1 is 2. Oxygen 2 times 3 is 6. On the other side, sodium, you can see it there, 1 atom. Chlorine, you can see that, 2 atoms. Lead, you see that, 1 atom nitrogen, you see that? 1 atom oxygen, you see that? 3 atoms there. So what do? We look for where we have deficient number. Chlorine is one of them. Multiply this side by 2. Go to this side and put 2 there. That will also affect sodium. So multiply this side by also by 2. You can see that. So that you are balanced, so you are balanced chlorine. Having done that, we'll now move to the other ones. I can still balance sodium again here. Okay. Sodium is bad. Yeah, these 2 multiplying chlorine also affected sodium, yes. So balance this sodium on this side and multiply by 2 as well. I'll go to the right hand side and put 2. But that 2 will still affect nitrogen and oxygen. So nitrogen becomes 2. That is times 2 now. That is 2. Oxygen becomes 2 times 3 is 6. And now it's no longer 3. So the equation is now a balanced equation. Before we go on with further examples, you have to get used to radicals. I'll give you a guideline. Any radical that ends with carbonate has valency of 2, like triazo carbonate. Carbonate 4 ion is a radical. Triazo is O3. Carbonate indicates carbon. See how I got it? Triazo, 3 oxygen. Carbonate indicates carbon. I don't need to bother about this 4 now, so I want to make it easier for you that is watching this video. So any radical that is carbonate is charge of 2. It goes with -2. Any radical that ends with sulfate also has 2. Triazo sulfate 4 ion is triazo SO3 is also 2, charge of 2, valence is 2. Radical that ends with also another sulfate is tetraozo sulfate 6 ion. So sulfate radicals also have valency of 2, like bicarbonate radicals. So get that to you. So radicals that might have valency of 2 are the carbonates and the sulfates. The nitrates have valency of 1, like triazo nitrate 5. You often come across them in compounds. NO3, triazo nitrate. Remember, the Roman number is not included in the formula. They present the oxidation state of the last element. So we're closing our eyes on the Roman number. They don't appear in the formula. Triazo, 3 oxygen, nitrate, that is nitrogen, 1. That's a minus. Radicals normally have negative charges. Then diazo nitrate. Nitrate again, 3 ion. Diazo means 2. Also have 1 negative charge. So valence of this one is 2, 2, 2, 1, 1. You can see that. Then any radical that ends with phosphate has valency of 3. Like if I have triazo phosphate 3 ion O3 PO3 has charge of 3 or valency of 3. Tetraozo phosphate also 3. So get used to the radicals and get used to their common charges. So that is it. We'll take another equation example of ionic equation. So we'll look at this reaction between 2 ionic compounds, acid and a base. Triazo sulfate 6 acid and sodium hydroxide. The first thing to do is to get the formula. This is a radical's name, tetraozo sulfate 6. So tetraozo implies O4. Sulfate implies S. We don't need this position state to make it shorter for us. Tetraozo sulfate. Then I told you the radical that ends with sulfate normally have a position state of -2 or charge of 2. Then acid. Every compound that is an acid contains hydrogen ion, whether that had it mentioned in the name or not. So acid indicates hydrogen. So you put the charge of hydrogen, which is +1. So when you now change to get the right formula, 2 goes to hydrogen, 1 goes to, when you want to give the radical, I told you use a bracket, 1. So that 1 from here now go to the radical, the 2 of them, the 2 elements, you have a bracket there. So this one has no effect because 1 times 1 sulfur is 1 times 4 gives you 4. So when you see 1 after the bracket, throw the 1 away. Has no effect. This is the form of the acid. Then sodium hydroxide have Na, sodium. The atomic number of sodium is 11, 281. Being a metal, having not more than 3 in the atmosphere, the valence of metal is what you see in the atmosphere with the same one you're seeing there. Hydroxide, the radical, OH. The valence of radical of the O hydroxide is 1 or minus 1. So having done that, we now exchange the unlike charges. 1 goes to sodium, here is 1, and 1 goes to bracket 1. The radical. Or you can as well just cancel the 1 because they're equal and join them together. You have the same NaOH. Because the 1, 1 are equal, they cancel themselves. So having done that, or having obtained the right formulas, we can now go to write the equation of the reaction between the two of them. So to write the equation, we have H2SO4 plus NaOH. Draw your arrow. The next, you split them into ions. How do you split them into ions? Remove hydrogen. The symbol, don't go with 2, because the symbol value is H, not H2. The element, or atom, sorry, H, because these two you should know came from SO4. Then I write SO4. So give them the valency, then return it the way we did when we combined, before we combine it. You are just redoing the process. Hydrogen is plus 1, SO4 is minus 2. Remove sodium, the first element, the remaining one goes together, OH together. That together is radical. Keep out the valency, plus, and then 1 or minus 1, the charge. So move unlike terms together. When you join these two, you now have Na2SO4. You should know how you come across these two. When you combine, as we always do, you check whether the 2 goes to sodium. We're having the 2 here. Why 1 goes to SO4, and 1 going to SO4 makes no meaning. Look at it. Again. So the 2 goes to sodium, and then 1. SO4 cannot take 1 and call it 41 because the 2 are together. So you have bracket before the 1. And 1 makes no sense. So now I have remove the 1, Na2SO4. Then join these two, you get HOH. HOH is seen as H2O, which is water. So having produced that, you then balance the equation. How do you balance the equation? You count the atoms and then check whether it's balanced or not. The atoms here, then our left hand side, our right hand side. So hydrogen, sulfur, pick the elements one by one. Oxygen, sodium, oxygen written before, hydrogen written before. Let's count. Hydrogen is 2 plus 1, 3. Sulfur is 1 only. Oxygen 4 plus 1, 5. Sodium is only 1. Repeat it again. Hydrogen is 2 plus 1, 3. Sulfur is only 1. Oxygen 4 plus 1, 5. Sodium is only 1. On the other side, hydrogen is 2. Sulfur is 1. Oxygen 4 plus 1, 5. Sodium is 2. Having done that, what then do we do? We now look at the table and inspect it very well, and then look at where we have a deficient number of atoms. Hydrogen is 3 and 2, but not be easy for hydrogen because 2 and 3 are not divisible. 1 and 5, okay. 1, 5 and 5. To go to sodium, 1 and 2. Multiplied by this side by 2. So the left hand side, you increase sodium. Go to sodium, you see it here, put the 2 in front. By doing that, the 2 affect oxygen and also affect hydrogen. Oxygen now becomes 2. What becomes 2 plus 4, 6. So this changes to 6. Hydrogen becomes 2 times 1, 2 plus 2, 4. Hydrogen becomes 4. You go back to the equation and then look at it, the table, and look at it again. You see that you have issues with hydrogen and oxygen. The one that is easy to balance is hydrogen because 6 is not a multiple of 5. but 4 is multiple of 2. Multiply this side by 2 to balance hydrogen. You now put the 2 here to balance hydrogen, making hydrogen 4. And by so doing, you're also affecting oxygen indirectly. 2 times 1, 2, plus 4, that gives you 6. By so doing, you have balanced everything. So look at this other example of ionic reaction. Triiodonitrate 5 acid and potassium triazocarbonate 4. An acid and a salt. Triiodonitrate 5 acid and potassium triazocarbonate 4. The first we have to do is to get their right chemical formulas. So these are the reactants. Triiodonitrate 5 acid. If you look at this, the radical's name, triazonitrate. Tri means 3, also means oxygen, O3. Nitrate means nitrogen. Don't worry about this number. I told you that nitrates have state of 1 or negative 1 at their charge. So an acid always contains hydrogen ion, which is positively charged. The formula of this compound, without wasting time or crossing, should be HNO3 because valency here is 1 and here is 1. Equal valencies cancel out. You don't need to waste your time crossing the valency or changing valency. Then go to this one. Potassium is K. Potassium, identify the element, it is a metal. 19, atomic number 2881, KLMN shell. The atomic shell contains only 1 electron. So it seems that only 1 electron is a metal because it doesn't exceed 3. So element whose atomic shell is 1, 2, or 3 is likely to be a metal. Or if it exceeds 3, it's a non-metal. And for metals, as I said, the valency is what you see in that atomic shell, which is 1. So this is 1, valence is 1, or it says charge plus 1. Then triazocarbonate is the radical O3. Carbonate is C. We are not after the position number for now. So I'm trying to make it easy. So triazocarbonate, and I told you carbonates have charge of 2. So instead of 2, so you have that. So the formula compound, when you combine the 2 will be, these 2 will go to potassium. This one here will go to bracket 1. So formula is K2C, because the 1 does not make any meaning. You remove it. So having obtained the right formula, you now go straight to write the equation. So you see that when you want to write an equation, formula matters a lot. If the formula is wrong, you're getting the problem 0. So having done that, have HNO3 plus K2CO3. So having done that, we're now going to get the product. To get the product, since the ionic compounds, you split them. Remove the first element, hydrogen. The remaining component will be together NO3. Put the valency back. This is 1. 1 or charge is -1. The first element, K, the first symbol, I didn't say go with the 2. Because these 2 must have come from the other one. And then CO3 plus 1, and then this one is 2. The 2 you have here, -2, that the charge. Valency being 2. You marry unlike terms together, these 2 go together. The charge here is 1 and the charge here is 1. No need to change. Since they're equal, you just cancel the charges and join them together. Have KNO3 plus. Join these 2 together. When you join these 2 together, you get H2CO3. How did I get the H2CO3? The 2 from here went to the hydrogen. You see why it's H2CO3. But should I write H2CO3 there? No. This acid, carbonic acid, is unstable. So whenever you get this acid as a product, it's very unstable. You don't write it as a product. What do? You split it into 2, water and CO2. So whenever this is formed as a product, we don't write it. We split it into 2 substances, water and CO2. Now write in place of this, write H2O and then CO2. So whenever you come across this, you have to split it in any reaction as a product. So having done that, we now have to balance the equation. To balance the equation, we have to go through it, and then the table, have our atoms, have our left-hand side reactant, right hand side product. Hydrogen, nitrogen, oxygen is 6. Okay, sorry, 4. Let's do the element hydrogen, nitrogen, oxygen, potassium, and then carbon. Oxygen have written before. Let's count. Hydrogen is only 1 atom. Nitrogen is only 1 atom. Oxygen is 3 plus 3, 6. Carbon is 2. Okay. Potassium is 2, sorry, that is this. And carbon is only 1. Repeat it. Hydrogen is 1. Nitrogen is also 1. Oxygen is 3 plus 3, 6. Potassium 2. Carbon 1. On the other side, hydrogen is 2. Nitrogen 1. Oxygen 3 plus 1, 4 plus 2, 6. Then potassium 1. Carbon only 1. So having done that, we then balance. You see that for hydrogen, this number is deficient. Multiply this by 2, the left hand side, you bring 2 there to balance hydrogen. And before you continue to balance the other ones, you have to change this side because these two affect nitrogen and oxygen. So nitrogen here becomes 2. So nitrogen becomes 2. You change it. Oxygen becomes 2 times 3 is 6. 6 plus 3, 9. Oxygen becomes 9. So by placing hydrogen, we are displeased these other 2 gentlemen. So having done that, we still go ahead. So I can start with, we have nitrogen, oxygen, and potassium. So it's not be easy to balance oxygen for now, so you're looking at it. But you can balance nitrogen, you can balance potassium. So let me start with nitrogen. We'll apply this by 2. Nitrogen, okay, nitrogen, we put 2 here in front of nitrogen. So we'll put 2 there. We're going to affect the element on behind nitrogen. Potassium is 2. We have potassium here becomes 2 now by doing that. Then oxygen becomes 2 times 3 is 6. 6 plus 1 is 7. 7 plus 2, 9. Oxygen now becomes 9. So every other thing is balanced. So having done that, we have a balanced equation. Having done that, we take another example. We have this one, hydrochloric acid and sodium thiosulfate 4. Already, this one contains hydrogen and chlorine. Valency 1. We have seen this example before. Chlorine is -1. So when you join them together, equal valency, cancel, you have HCl, the formula. Sodium, we have Na. Total number of sodium is 11, being a metal, 281, not more than 3 in the atmosphere, donates 1 out. Metals, electron donors. The valence is what you have in the atmosphere. Triazo is O3. Sulfate S. And I told you that sulfate radicals have valency of 2. I said that before. So the formula of compound form is now Na2SO3. That is 2 coming to sodium and 1 going to bracket 1. So that one is not relevant. So having done that, the equation have HCl plus Na2SO3. You have the reactants, then join together with a plus sign. Then split this. Have H, split from chlorine. Even the first element, this one go together. Return the valency, that is return it the way it was before. You see that it's the same thing, bringing it back to the previous form. So plus, minus. Take the first element here, the first symbol, sodium, then SO3. So the valence of sodium, can see it there, is 1. SO3, 2, can see it. Return it to their previous form. Then combine unlike charges. When you combine these two, you have NaCl. Nothing is changed because valency is 1, 1. 1, 1 cancel each other. So that's the formula. When you join these two, you produce H2SO3. So when this compound split, it's unstable. So it will make unstable compound. The one we made before, which is H2CO3. So they're similar. H2SO3 and H2CO3, they're unstable. So whenever they appear as product, they must split. You split them into 2. This should be H2O and SO2. This one should be, we use the product H2O and CO2. So this is what we have now. H2O and SO2. So you see that some compound that split when they appear as product. This and this. Another one is the one we call ammonium hydroxide. If it's ammonium hydroxide that we have, MH4OH, is going to split into ammonia and water. So these substances, when they are formed as products, we don't write them that we have to split them into these components, a gas and water. I see that. Be conscious of that. So having done that, let us balance this equation. To balance the equation, I don't think it's balanced. So we have hydrogen, chlorine, sodium, sulfur, oxygen. Left hand side, right hand side. Hydrogen is 1, chlorine 1, sodium 2, sulfur 1, oxygen 3. Go to the right side. Sodium to hydrogen first, 2, sodium, chlorine, 1, sodium 1, sulfur 1, oxygen 3. That is 2 plus 1, 3. Having done that, we now look at it. So the hydrogen is deficient. So I can multiply this side by 2 to make hydrogen balance. The left hand side, put 2 here. And that 2 affect chlorine, making it also 2. So I have chlorine on balance. I have sodium on balance. So I can start with any of them. So maybe I can start with chlorine, multiply it this side by 2 again. Product side, put 2. And that will affect sodium. So now also becomes 2. So by so doing, the whole equation is balanced. So having done that, you see, these are easy things to do. Other examples of equations that we meet in chemistry, common ones are combustion equations. Could be hydrocarbons. Maybe someone asks you equation between butane and oxygen, or combustion of butane. Equation to show the combustion of butane. Butane, that's the name, hydrocarbon, is an alkane. So for your basic chemistry or your high school chemistry, you are learning the alkanes. So what the problem now is to get the formula of butane. So you should know all alkanes. Alkanes have the formula CnH2n plus 2, where n starts from 1. So the first member is methane. For methane, n is 1. Ethane, n is 2. Propane, n is 3. Butane, n means number of carbon atoms. I mean that n. Pentane, n is 5. Hexane, n is 6, and so on. So if I want to get the formula of butane now, I'm going to put 4 here. Since the compound is butane, n is 4. I have C for replace n with 4. H2 times 4 plus 2. Replacing n with 4, that will give you C4. Then this is 8 plus 2, giving us 10. This is butane. You see? Likewise, I want to get E10, you put n as 2, you're going to get C2H6. You want to get pentane, you put n as 5, you're going to get C5H12. And so on. That is for alkane nomenclature. So, since we want to write the equation to show the combustion of butane, so butane is C4H10. Combustion means burning butane in oxygen. Oxygen is diatomic, O2. You see? And when hydrocarbons burn, they produce CO2 and steam. You have to know this from residual knowledge. You should know it. So having done that, you balance the equation. To balance it, you can just draw your table or use try and error method. Carbon is 4 here. You put for your balanced carbon. Hydrogen is 10 here. Here is 2. You put 5 here to balance hydrogen. You can see it very well. Carbon is 4. Hydrogen is 10. 5 times 2, 10. What remains is only oxygen. 4 times 2 is 8. For oxygen here, 5 times 1 is 5. 8 plus 5. 8 plus 5 is 13 oxygen atoms. But here I have only 2 oxygen atoms. 2 and 13. 13 is not a multiple of 2 because 13 cannot divide by 2 unless we remember. So what it means is we're going to apply fraction because oxygen we want to balance is on its own. So any number we put here now will balance only oxygen because it's on its own here. Every other atom is balanced. So what you do, divide the bigger number 13 by the number you have here 2. You have 13 over 2. Use the fraction. So having done that, you then clear the fraction as I taught you in equation balancing. To clear the fraction, multiply everything by 2. The method here, you have 2C4H10 plus 13 over 2 times 2 gives you 13O2, us 2 times 4, 8CO2, 2 times 5, 10H2O. So you see this is the balance equation. Carbon is 8, 2 times 4, 8, 8 times 1, 8. Hydrogen 2 times 10, 20, 10 times 2, 20. Oxygen 13 times 2, 26, 8 times 2, 16, 10 times 1, 10, 10 plus 16, 26. As simple as that. So having done that, what if I use another hydrocarbon? What if I use a combustion of, perhaps, I say combustion of, let me say propene. Propene. This one ends with E, means an alkene. Alkenes have the formula CnH2n. Of alkenes, N starts from 2, not 1, as alkene. So the first alkene is called ethene. Alkene has nothing like methane member. Ethene, N is 2. Propene, correspond to propane, N is 3. Butene,